Welcome back to Worth the Effort Woodworking. Today we are going to make one of the handiest tools I have in my shop. It's one that I keep in a place of honor. Right next to my marking knife, my pencil, you will always find a gauge like this. And officially I call it a dovetail marking gauge, but that kind of diminishes its usefulness in my shop because I'm using it on just about everything. I mean, a lot of people keep a little 4-inch combination square round. Well, I keep this thing. It's so much handier, so much more compact, and if I damage it or lose it, I don't really care because it doesn't take much effort or time to make a new one. And today I'm going to show you two different ways of making it because I'm going to kind of try to editorialize this video and prove a point. Because I get comments all the time and I think it's utterly stupid. And a lot of other content creators comment that they get the same things, and it just doesn't make sense. It's those people that are saying, well, if I had that shop, or if I had those tools, I could. Well, I mean, that's just, you're trolling yourself. You're putting an obstacle in front of yourself to prevent you from doing something. And you can almost guarantee it's a new woodworker. It's a mental block to even trying. Hey, I don't have the big bandsaw. I don't have the big table saw. I don't have 100 different turning gouges. Well, you have all you really need if all you're trying to do is create a specific build. Most content creators have had enough of an interest in this subject matter that, yeah, they've invested in tools over time. I mean, I myself have a decent set of tools that y'all have seen me kind of accumulate over my entire YouTube career. Because when I first started, I had a very, very basic set. But look at the stuff I was building way back then. So starting small isn't really that big a hardship if all you're trying to do is accomplish the task of building something. Now, I also kind of think it's funny that you talk to a lot of these big-time woodworkers that have big shops, lots of employees, equipment all over the place that just would have most of us drooling. And what is their retirement fantasy when they're all successful with the career? Get rid of everything, come back to a small shop with a limited set of tools, and just go out there and build for their pleasure, not for profitability. Then again, you do have individuals out there that have built entire buildings, all the latest doodads, the greatest quality equipment out there, stuff that would make a pro shop owner just drool. And what do? They'll spend a little bit of time out there every few weekends and maybe a portion of their vacation, make 1 or 2 items a year. It's just their hobby, but they've invested in that hobby. They've invested in that interest in a manner that makes them happy. And who's to say that's even any worse than somebody going out and buying a nice car to show their level of success in life? I mean, they've worked hard, they've achieved a lot, they just want to go out and relax and have the nice equipment that they can enjoy using to make something that makes them happy, that makes them feel good about themselves. There is nothing wrong with that. And if they're generous enough to actually share that experience by creating content and showing us what build, why should we complain that they have the nice shop, so that's why they can build this stuff? It's just they've taken a few luxuries in creating minor steps into removing wood fibers. But for the most part, big shops with lots of fancy equipment are generally there to make production woodworking a little bit easier, a little bit more efficient, and a lot more repeatable. Because those kind of people that are investing into it and producing that much quality product, they're trying to make a living at it. And they're looking for the most efficient way of doing it. But just because you don't have as an efficient way of doing it doesn't mean you can't accomplish a task at all. So today I'm going to be making 2 different versions of my marking gauge. One with some very rudimentary tools using some of the most basic skills I know of. Basically the equivalent of drawing within the lines. And then I'm going to make about 250, 260 more in a production mode using power tools. Some of the equipment a lot of people think they really do want in order to make one item. So, let's get going and start making some new dovetail markers. So here's a basic design. You have a 3/4 inch wide board, and it's 3/4 inch because that's kind of our standard size for a lot of cabinets material we make nowadays. And then the blade that runs up the center is an exact 1/4 inch. That way, if you're ever doing mortise and tenon joints, you can basically just lay this on a board, find the center, and mark either side of it for your mortise and tenons. And then that'll be the perfect tenon size if you're taking measurements there. One side is going to be a perfect 90 degrees, so I can bump this up to anything and mark out my 90 degrees. The other side is going to be a 45. And if you ever do dovetails, one of the most common dovetails out there is a mitered dovetail. So you can get a nice 45 degree on top of the cabinet or something like that, but the interior is just a through dovetail for strength. Then on either side, it is marked out at my favorite angle for dovetails, 1:7. It's just a good average. You can do whatever you want, but you have to get the angles precise. You have to get the thicknesses precise. You have to get the tenons precise. This isn't just to throw it out there and see if it'll work. It's got to be repeatable. Dimensions wise, I like to make my 90 degrees a little over 1.5 inches long. Simply because if I'm marking out or gang cutting dovetails, I want to be able to mark across 2 3/4 inch boards at the same time. So getting a tad bit longer than that lets me put the knife on the far side and bring it over. Now, if you go over your hole ratios, I generally, as I said, this is 3/4 of an inch because this is a 1/4 inch, and that'll allow me to center it on a board. And if I go over a 1:2 ratio, I make this 1.5 inches, and it just feels right. It looks right at that size. And then if I double that again, I make the entire length a little over 3 inches, and that'll let me do the 1:7 and the 45 degrees at least across one 3/4 inch board. And I don't really have any reason to gang cut those angles, so it's okay there. Now, if you are hand making something, you can just go find a piece of wood. As long as it's bigger than what you need to end up with, there you go. And whenever we make these, I always tell students to make them 2 at a time. Not only does it make it easier, but if you screw up one, well, you can kindle that one and use the second one. It's a backup, so to speak. I just went to my pile and found an offcut from another project, a turning project. So this was something I got straight from a tree. It's a nice pecan, and I kind of like the color between heartwood and sapwood. So I'm going to use that. But if you're doing production style woodworking, then the ultimate goal in the machines you invest in and the material you buy is to reduce the amount of time you have in each specific step, in each specific product. You want to make your labor as little an investment in the final product you sell as possible. And in that kind of situation, it's always nice to start out with very consistent, almost homogeneous material, or as homogeneous as you can make it. Go out and buy a 5/4 piece of cherry, very even, stuff like that, so it reduces the amount of steps you have to do. But if you're in a situation like I am right here, and you're trying to do a production run using up scraps, because basically all we're making is a small item, so you don't have to be perfect, just little perfect sections within each board, you at least have to start out with something that is consistent. Now right here, I have that 5/4. I have a board, I don't even know where it came from. It's a gnarly piece. I have the rest of that pecan piece I used with a hand tool. I have an 8/4 white oak. I have some other scraps. I'm just going to try and use this all up, but in this wide variety of shapes, I need to first create something that is consistent across all of them so that I can set up the machines later on down the road to get consistent results back. Now, working by hand, we still got to do a little bit of dimensioning, but at this time, because you're going a little bit slower, you get to kind of look over your work and just determine, hey, where do I want to get this tool setup out? Is that 1.5 inches? Not quite, so I need to go this way. Okay. So dimensioning, You know, if you have a chop saw, that's all great and wonderful, but I have a video out there showing you how to make a miter box for in less than 5 minutes. And just grab your saw. You know, even a really nice one, you know, 60 to 80 bucks. And then just measure out what you need. I want to make each one, you know, I said that about 3 inches, so maybe come out about, let's go 8 inches to give ourselves a little bit of slop. Come out here, just measure that out and saw it off. Now, I know a lot of people out there are going to come across this video and say that he's just being a condescending prick. But it's the idea that people are actually using the fact that they don't have $20,000 worth of equipment, which I don't have that much, so that they can't make, you know, a small box, a table, or anything like that. It's just stupid. I mean, the first few videos you see on my woodworking channel were made in the corner of a 400 square foot efficiency apartment with a lot of the hand tools you're going to see me use today. I mean, I invested back then in them. I'm still using them to this day. And the workbench you saw me using in that video was a solid core door on a 2x4 frame that was held together with those Simpson screw the corner galvanized steel things. I think I paid 20 bucks for build a table with that, and then I just put that galvanized top right on top. And there isn't much that I do now on this nicer workbench that I couldn't have done back then on that solid core. I mean, I'm just single point doing right now. I did the same thing on that one, just putting a board across it and clamping on both ends. That gave me something to bump up against. Not that big a deal, and that was a lot less money than this poplar table I'm using now. I mean, you really don't have to spend that much money if you don't want to. So I now have a flat face here and a flat reference there. So what you just saw me do with that simple hand plane in just a few minutes of creating a flat face and a flat 90-degree edge, in this particular project I have to do the same exact thing to all that randomly sized rough work. Now, unlike if I was making a table where I have a large flat surface, these are small items. So the flatness I got from buying this particular board, it being skip plane, it's pretty much flat enough. But you can tell on this jointer that it is no way near 90 degrees or flat here. So I need to get this down to a perfect 90 degrees. And that's exactly what a power tool like this jointer is designed to do. Yeah, I know in hobby shops, you know, they'll do recessed rabbets, they'll cut different angles, but most everyone I know that has one of these things basically sets it up to take a 90-degree pass and flatten an edge. Now for me, this was a $400 purchase that I got at one of those refurbished places, factory direct, you know, where returns come to. They check over them, make sure everything's okay, then they resell them at a pretty big discount. And for what I do, small production runs, this is a real time saver. That $400 price I've gotten back many times over in labor savings. I mean, if you think about it, somebody that you're paying $30,000 a year, that's $15 per hour. $15 per hour into this thing, that's basically 26 hours. The first time I saved 26 hours of labor hand planting those boards flat, I paid for the item. And once again, that was years ago. So, in a production environment, it makes sense to start investing in tools like this. Or if you're just a hobbyist and that's not that big of discretionary income, you could buy a machine like this, set up in the corner, and you know, it'll take a few seconds each time. Now the thing is, a lot of people will sit there and say that, hey, well, if I just buy the machinery, I don't have to learn the skill. That couldn't be further from the truth. you have to learn a different skill. You have to learn where to place the pressure. You have to know how to set this thing up. Because something like this is never going to come perfectly from the factory, especially if you're buying used or at the price points I can afford. I mean, I had to put shims in here to get this perfectly level. And yes, the more money you spend, the less fiddling you'll probably have to do. But it's one of those time, cash investments, balancing acts that all woodworkers have to do. If you don't have the cash or you don't have the space and you're just making one item at a time, that inexpensive hand plane starts to look pretty attractive. Now, what I'm not saying is that you have to eschew all power tools, but be selective. My personal opinion, I would not want to do without the bandsaw, because a bandsaw can do pretty much everything I would do with a handsaw. And getting a nice handsaw collection costs about as much as buying a used bandsaw. And you don't get a figure like mine sweating a lot pushing those handsaws around. A bandsaw, I mean, I much prefer this over something like a table saw, especially if I was in a small garage shop, because you can just put it in a corner, where a table saw pretty much takes up your shop. Plus, this will do most of the grunt work. And if you're willing to search them out, you can find really good used ones, even going back, early 30s, 40s, 50s. Because I hate to say it, bandsaws have not changed that much. Unlike something like a table saw, which personally, I wouldn't buy anything but pretty much the latest and greatest out there in the table saws, because some of the older ones you can't even fit a splitter, much less a good quality riving knife. And that's some of the best ones out there, like those old Powermatic 66s, not without a lot of fiddling. So even some of the modern day safety equipment like riving knives, I feel are a necessity. So a table saw, no matter what, you're looking at a couple $1,000s likely. And if you look in the corner of some of those early videos of mine in that apartment, you will notice that I had a little tiny 10-inch Craftsman bandsaw over in the corner. And I want to say I paid $35-40 for it, and probably $100-200 in blades over the years as I was learning. But that got me started. And with that and a few hand tools, in practically real time, you've watched me dimension the material I'm going to need for this project. Let's go. The kicker is that it doesn't really matter if I'm doing a production or kind of a one-off like you just saw me do. The steps are pretty much the same. I've got to dimension this project so I end up with a 3/4 by 1 inch by 7.5, 8 inches. So even on a table saw, it starts with just doing a bunch of repetitive cuts. And in a production setting, the table saw is the better choice. In a small shop where funds are limited, as I said earlier, I believe the bandsaw is a better one, because you can cut a straight line and then just plane it back and end up with a very precise cut. But a table saw blade is not only going to be a little bit more efficient, it's going to be a little bit quicker going through the product. It's going to end up with a smoother finish that you might be able to sneak by with going straight into glue ups and stuff like that. So this is much better in a production run setting. And I'm going to admit to you, I don't have the best table saw out there. This is kind of where my budget is at. Just a cheap little contractor saw that I've had for I think probably 5 years now. Now, I just mentioned that on the table saw, so I'm going to get this further refined, because This is going to be a high precision tool. I've got to make sure that they are completely parallel on both sides, so that when you have that 90 degrees you reference against something, it doesn't matter if you mark on this side or that side, it will be perfectly 90 degrees. If this was a parallelogram, well, you can make one side a perfect 90 degrees, but that would have the other side off. So we've got to make sure that this is perfect. Now, if you can see, here's that line I just did with the marking gauge. And to show you that difference, that right there is maybe a tad bit more than a 64th of an inch. Right there. And I made that all the way around, and it's pretty close. It's actually close enough for most woodworking, joinery and stuff like that, getting this board parallel all the way down. But I want to get it a lot better. So I've got my grain running uphill this way. I'm just going to flip it over, and I'm just going to plane down to that line. And you can really, you know, if you're taking a few thousandths of an inch off, you can really sneak up on it. If you're a little bit more on this side, just start over here, take a few swipes, and come back. If you're a little heavier on this side and less on that side, which we are in this case, well, what I can do is I can use my fingers and I can shave off a little bit on one side and work my way across. Now, me personally, I keep a slightest of camber in here just so that I can do that kind of application. And after a few swipes, you're going to see that they're about equal right now. Coming around, check, just watch it, and eventually, because I use that marking gauge which indented on it, this is going to feather off, and that's when I can tell I'm just right on that line as it just kind of flakes off on the edge. So I'm going down the center of my blade, which is curved right now. Takes off even amount, and yep, we are getting really close. Probably a little closer on this side than this side, so I'll move my plane over a little bit to take a heavier cut on this side than that. And there you go. The telltale sign that I am getting close to that line is it kind of starts to feather off like that. So I'm just right there. Probably one half swipe and then a full swipe, and I'll be even all the way around. Half swipe, full swipe. And here you are talking about accuracy, feathering off down to a couple thousandths of an inch. You want to try getting that off of a table saw? So after about an hour and a half of just sitting at that table saw, I made one adjustment. I went from a ½ inch to a ¾ of an inch. This is all that's left of that stack of random sized wood lumber. Something fairly consistent. And I say fairly because just like with the hand tool, I just use that hand plane to get it to the precise depth. Well, something like that contractor saw, there are a lot of variables in there. It's not like a cabinet saw. So even if you are stepping up to a power tool like that, you might not be able to get the results you want. Because I can guarantee you, if I come along this board, even though it was taken on the same cut, there's going to be about 1/128th difference from one spot to the other. So in order to get an ultra precise dimension, which I need in a production woodworking setup because it's going to be sitting in jigs, I've still got one more power tool to go. And that power tool is going to take the place of that really fine shading I was getting off of the plane coming down to that line. And that's the drum sander. So next up, I'm just going to square up the ends. It's not a real big necessity, but it'd be nice. And I do notice that the one I did out of that miter box, it's pretty much dead on end. I can see a sliver of light on one side. The other side was done with a chainsaw, so it's way off. So let's square that side up, and then we'll true it up using our hand planes again. Now it is real nice having something like a chop saw, miter saw, or table saw, and just being able to walk over put your crosscut sled in there or set it to a stop to cut off a perfect 90 degrees. But if you don't have the money for that nice equipment, hey, you can make yourself a very simple square. And I mean, all you have to do is get something that's 90 degrees. How do you know it's 90 degrees? Come over, swap it this way, flip it over, and check it. And I will do this every few times. You see all these pencil lines along the side of my desk. That's me checking out my square to make sure that it is perfect. And then just a nice knife. I find knives are a lot more accurate than pencils because it's a thinner line. And if you know how to mark stuff out, and this is all stuff I cover in my classroom series, well, I now have a perfect 90 degrees all the way around. So all I gotta do is grab that same saw and another little jig, little bench hooks. And using proper sawing techniques, I can saw off a perfect square. Notice how my finger's just gonna guide it over? Now I've covered a lot of sawing techniques in my classroom series, so if you want to check that out, it'll kind of explain all these little cheats I use to saw accurately, because I am not the most coordinated out there. I'm just using my fingers as little fences to get the cuts accurate, and I'm creating a path of least resistance for my saw to follow. And that's really all there is to it. There are other tricks where you can make little V-cuts and stuff like that, but with a little bit of practice, they're pretty much unnecessary. All you gotta do is create that path of least resistance. Now, in order to get it perfect, we can use a shooting board. A few shavings, and it'll get everything nice and plump. Basically refine it down that last, quarter degree or whatnot. Flip it over, do the same thing to the other side. But I can hear it now. People are going to be out there. Hey, you're telling me these low buck methods to do stuff, but you're pulling out all these tools. I don't have a shooting board. I don't have a bench hook. Well, my statement is, make the damn things. Don't be lazy. You might not be able to carve one out of a solid block like I did here, but there's no reason why you couldn't get a 1/4 inch piece of plywood, a 3/4 inch piece of plywood, use the factory straight edges, and just glue it up so you have a little raised portion for your plane to come along for a shooting board. Or, once again, glue them up. Got a little ledge, got a little thing right here. If you really want to, you can figure out how to do just about anything in woodworking on a fairly small budget. It's only when you start mass producing stuff where investing in a lot of equipment starts to make financial sense. But who said hobbies have to be financial? Once again, some people buy boats, other people buy table saws, jointers, band saws, planers, belt sanders, drum sanders, and all that kind of stuff, and still spend less money. Now we're coming up to the most critical cuts of the entire piece, and that are the layout lines. Now the most important one, in my opinion, is this 90-degree one, because that is what we use to reference off of everything, this 90 degrees. If that's even a fraction of a degree off, well, you're either going to have to refine it or toss it and make a new one. So when I'm teaching students, I always like to start out with these 1 in 7s, because if they're actually a little bit off, these are what we use to mark out our dovetail lines. And if one's a 1/2 degree off than the other, it doesn't really make that big a difference. Nobody's going to notice it. It's still going. There's nothing that's going to be negative about that one. So practicing these cuts first just makes sense. Then I'll go to the 45, because not many people will use a 45 unless you're cutting dovetails this small. So, and really it's not that big a deal if it's a tad bit off, because if you understand mitered dovetails, you can curve it. But that 90 degrees just has to be perfect. But I do start out measuring the 90 degrees because I cut them on the end, because I find it's easier to cut accurately if you have a large block of wood to reference again. If I was cutting it in the center, we wouldn't be referencing that much. So I tend to cut 90 degrees on the outside and my angles on the inside for that reason. So I'm going to come in a little bit more than 1.5 inches. How much more? I'll leave that up to you. Just a little bit over. I'm going to make a neck. And notice that is on my original reference side. I always refer back to that. And I'll do the same to both ends of the project. Just a little bit more. Just so that it'll stretch across 2 3/4 inch boards. And there we go. I have my 2 necks, and then I'm going to mark out these 2 lines using the square I checked. Now, even if you have a metal square or plastic square, I do suggest you check it before you make any kind of critical 90-degree cuts, because you don't know if temperatures, humidities have changed, it's been dropped, or whatnot. Do the same to the other side. So I now have my 2 90-degree marks, and you can do the same to the 45s on that end. And once again, it doesn't have to be all the way across. Just make sure your cuts are nice and deep by going first extremely light, then a little heavier, and a little heavier each time until you get a nice deep cut. I also take into consideration grain direction, because you see the grains running here. So if I mark this way, the grain pushes the knife into the blade. If I mark this way, the grain wants to let it fall off this side. So I always like to, when I'm doing 45s, to go so it takes advantage of the grain. Now, getting the 1 7 angles is pretty easy. Just pick a spot, come out 7 inches, and then measure out 1 inch. You can draw a line. Now, if you do that on a solid board and you're going to be repeating this angle quite a bit, there's no reason why you couldn't cut something out like that out again if I would. Me personally, I just kind of take a angle gauge because I know I can reset this at any time. And then it's just a matter of marking out your lines. Doesn't really matter which way or the other. Notice I have not marked them across yet, because I've always found that when I'm laying these out, when I'm using this tool as a dovetail marker, it's really easy just to rotate it, to flip it like that. Works out pretty well. So I like to have both the ramps going in the same direction. So what I would do in this kind of situation is I will take those mark out lines and I will transfer them over. I'm just going to use this because it's in my hand. Transfer it straight over, just like that. Make a nick on there. Do the same thing to the other side. Just make a nick. You drag your knife across, you can find the nick, and then transfer it over. And do that one for both sides, and you should be able to just transfer that angle line from one side to the next, and they will meet up. You now have 45s and 1 7 on one side. So now you have your 45s, the 1 7 on one side, your 90s, and the opposite 1 7 angle, ready to cut out. Last thing we want to do is mark down exactly 1/4 inch on both sides. That way, since this is 3/4 inch thick, you'll end up with that 1/4 inch center blade. And I do that with my wheel marking gauge, fairly simple. Same tool I used at the very beginning, and that's making sure that both sides are going to be very parallel. So the end of dimensioning in my production mode is a bunch of these. And basically I have them perfectly sized, 1.5 inches, 3/4 inch. I was very precise on that, going to my calipers. And then I got this distance close, but not perfect. I did this on the chop saw, and while the chop saw is a good production tool for like construction and stuff like that, I have never found one that's going to be perfect for furniture making, because a 1/2 degree off here will translate throughout a project. And I've dialed in my chop saw as best I can over the past, I want to say 12 or 13 years, and I've always found that it's anywhere between a 1/2 and 1/4 degree both directions. So I just kind of get it close to the middle and I've stopped worrying about it. This is just a rough dimension for me. The rest happens on the jig I created. Now, production mode for me means eliminating as many steps as possible and then sitting in front of a machine without changing any settings for hours on end. I mean, it's pretty much taking the creativity of a project, the skill of a project, and turning it into process. And that's what I've done with this jig right here. I'm not going to bother doing all those layouts. That would take too much time. And I want to do the layout and the cuts at the same exact time. So I've got a jig where I can reach over here, grab one of my blanks. Using stop blocks, I can get it perfectly square because I have dialed in this crosscut sled. And then I can cut out my 90 degrees off of a stop. I can cut out my 1 7s. And then I can cut each individual item. Now, I built this jig before I started putting the 45s in there. So what I will do is, right before I cut out each individual one, because each one of these blanks is going to create 2 dovetail markers, I will come over, hot glue a very precise triangle in a spot that will let me get my 45-degree cuts. And then have at it and do all the 45s at once. Once again, setting it up and then being able to process a bunch of stuff through it without changing the setup. Let me do a run through and show you everything. About working with hand tools. When you're working with power tools, pretty much everything has to be pretty precise because you're doing repetitive cuts, you're making 100 items at the same time. You kind of need the results coming off the power tool to be consistent. When you're working with hand tools, you can pick and choose what has to be consistent. Now, for example, I've stressed really hard that the 90 degrees have to be perfectly 90 degrees straight across. But it does not have to be a perfect 90 degrees straight down. If I were to undercut this a little bit, instead of going straight down, to undercut it a little bit to the inside to create just the slices of V, that will mean whenever I use this tool to engage a certain portion, well, it will touch on the bottom, but not at that interior angle. And that could be pretty cool because sometimes when you're rough cutting stuff, you get schmutz on the end, tear out stuff that sticks out that would interfere with registering straight against that interior corner. So if it were to touch a little bit below that and be perfectly 90 degrees, well, you would remove that chance of being schmutz. And that's one thing about hand tools that I like. It gives me the control of where I need to be precise and where I can fudge it in one way or the other a little bit. I do that same kind of fudging with that interior angle, whenever I cut the tenons of a Morrison tenon joint, because I'm only concerned with this outside corner engaging the side to be tight. If that interior corner had a little bit of gap to it, no big deal, as long as it was gapping on the interior corner. If it was closer on the interior corner than that face, then I would see a line there. And if you're draw boring where it's going to pull that tenon in, well, having it that slightly interior will actually crush the face fibers a little bit, because that is end grain, and it will really take a tight joint because it's crushing that fiber to be a tight joint, and it ain't going to loosen up. So that's one thing that with a smaller price toolkit, you have a little bit more flexibility. Just a little side note. So now we have the baseline that we're going to be sawing to and the angles we're going to be sawing. So now it's time to get cutting. Now in the classes when I was teaching it, remember this was the first thing we did before dovetails, to practice sawing to that line. But what I would tell students to do is grab a really sharp pencil and start making a bunch of lines in this interior portion in between your two 1 and 7 angles. And this will do two things. It'll give you a lot of practice sawing to the line, but it's also going to break up these fibers to make them easier to clear out at a later date. Now this time I'm going to switch to a low gent saw for the simple reason I taught a lot of kids classes, and kids seem to have better, easier time using these gents than the pistol grips, and just through repetition I'm a little bit more comfortable there too. But once again, it's just an inexpensive saw. This is, I would call it a medium to low priced saw. It's a decent quality. So we got ourselves a little wax. We got our saw line, so you can come over, position it with the fingers, start on the far corner, saw all the way across the face, come down to your baseline, making sure you stay in that far corner. Use a full saw plate and then ride it up. Just make sure you stop before you hit your line. So now that I've had all this practice sawing all these practice cuts, now it's time for the real thing. So without doing any V cuts or anything like that, I'm going to put a fresh coat of wax on my blade, come over, simply put it right on the line, get it going, use my finger to follow that line. I mean, this really is as complicated as drawing with crayons and staying in the lines like you did in kindergarten. Now once I've taken a few strokes, I'm going to angle the blade a little bit. Not much, just a little bit to undercut it. Come down to my baseline, right it up. And if I were to go past that baseline a tad bit, wouldn't be that big a deal. And there we go. Still got to go a little bit farther. At which point I can do the same thing to all 4 other 1 in 7 corners, giving me practice. And what's cool is I can look right here and see the knife line. It's a lot darker because there's a slight angle there, which means it tells me I just got it right on the money. If you couldn't see that little bit of a bevel caused by the knife, you know you might have come over a little bit. But on this 1 in 7, remember, it doesn't matter. We're only concerned when we get to that perfect 90 degrees. So we got lots of practice to go. And then once you've got all your waist, your 1 in 9s, your 45s, now it's time to go for the money ones, the 90 degrees. You've had all that practice, let's go for it. Just get it right on the money, and if you don't get this one right, you have the one on the other side that's going to be perfect. Start the saw, follow that line all the way across, angle it down a little bit. There you go. Easy peasy. So after that 45 and 90 you you've gotten all the critical cuts done. Everything else is just removing waste, and they aren't as key. But it's also very good practice for a lot of your other joinery, such as Morrison tenons, cutting this tenon shoulder. Now I'm going to use this Moxon vise here. Once again, you don't have to have a clamp like this. This literally is a loose board with 2 screws going through it. So if you can somehow secure a board to a table and then get 2 clamps, little quick vise clamps to squeeze your work to it, there you go. You have your Moxon vise. This is just convenient for me, and it's something you can make without a lot of money investment. So I'm just going to drop it in there and saw away. Using the same gent saw after a fresh sharpening because I thought it was a little bit dull. I come over, just drop it on the line, and saw down the face. I like that on this angle, but oh well. Saw across the face. And then connect the dots. Looky there, we got a nice 45-degree angle. If you have any schmutz whatsoever in the corner, just clear it up with a chisel. Now cutting the 90-degree cheek off, it's pretty much the same exact thing. I started on the corner, did top, came down to the angle, and now all I have to do is keep sawing until the saw gets upright. And I'm a little bit off on this one, but for the function of the tool, that doesn't really matter. It's still going to mark 90 degrees. I just keep sawing until it pops off. There we go. And if I wanted to get it dead perfect, you know, I could take my chisel to it, but I'm happy with that. Now at this point in time, I would generally give my students a choice. Because this is a good practice for Morrison tenon, I would let them choose. Do they want to saw off the interior, the 1 in 7 cheeks, or do they want to learn to chiseling it off? And it's about half and half. If you wanted to saw it off, basically you would just cut it in half, go to the saw, and do the same exact process. If you wanted to learn to chisel it off, I would tell them go to the vise, and once again, you can use this with quick clamp vices on any table with a reference. But I would tell them to go to one of my leg vices, bring the table up so that it would register against it, but be a tad bit below the line. You just want it as a brace. And then tighten up that clamp a little. Then observe which direction the grain was going. If you notice, the grain is heading downhill on this way. So if I were to chop going down here, there's a chance it would split into what I want to keep. So I actually want to chop in this direction because the grain is going this way. So as I chop, if it cracks, hopefully the crack will go off into the distance. So I come back over, just hold it there, grab my chisel and mallet, only take half the distance, and then just give it a little chop. And right about the time they got halfway, I would threaten them about chopping into my workbench. If that makes them paranoid, you know, they can always just loosen it up, drop the a sacrificial board underneath it, tighten it all back up again, and start over. That way, if they chop all the way down, who cares? But there you go. Work your way halfway down, chopping. And then keep going. Take half the distance to the baseline each time. And notice I'm standing to the side now because it's much easier for me to see that the chisel is perpendicular standing here than it is standing here. You always want to stand to the side when you're chopping on a chisel. You're right at that knife line. You should be able to just drop it in that knife line and kind of lean on it and shave your way down to get an extremely smooth cut. Something that you can refine with a card scraper to get a finished surface. Now, if you do have a power tool such as a bandsaw, which once again, in a small shop, this is probably the first power tool I would get because the flexibility of it is so good. And as I said, it can do a lot of the tasks you do with a handsaw. Well, I mean, there's no reason once you cut the angles, you couldn't just come over the bandsaw, set your fence, and then just cut all the shoulder cheeks off. Even the angled ones. As long as you can keep some portion of the pivot point on the ground, you could actually lift it up a little bit to create that angle and slide through it. And this would even work in a production shop because it's just so fast. And a lot of times I will do this for parts that aren't seen. Because while a bandsaw can be incredibly accurate, it's not going to give you a very smooth finish. And once again, in production work, we're trying to eliminate as many steps as possible. Which is why in a production run such as this, I'm going to go to the table saw to cut these cheeks off, just because the final finish is pretty much ready to go. I'm not going to do too much after that. And once again, we are in production mode. So we are basically turning as much of the individual steps into a process that can be repeated quickly and easily. Right now, we've got to cut tendons off. And if you know anything about table saws, cutting tendons can be incredibly dangerous because you got tall, thin pieces that you're running across that way. That's why they make special tendoning jigs. But, A, I don't have the money for that one. And B, a lot of times the way they design those things, it's kind of time cumbersome. You got all these screws and stuff like that. And I've got 4 tendons on every one of these devices and well over 200 of them. So that's well over 8, almost 900 tendons to cut. I don't have the time to spend all that in. So what I've done is I've created a 2-part jig. Something really tight and close that I can drop these into. And then a second part that's going to hold it on top and help push from the back. So everything's locked together so I can come over, drop my piece in, making sure I've got the tenon I'm cutting on the outside and what part I am, set my blade up, and then this will fit on top and lock everything together to make it a smooth push through. So I will do all of these tendons at one time for the entire set. Now peel these off, reorient them so that they will hold this at whatever angle will get the blade going flat. Then raise or lower the blade to that level. And it should go, I should be able to accomplish all these tendons in half a day. So there we go, 280 some odd dovetail jigs plus one. One I made with a very limited set of tools and the most basic of skills. Something that you could develop in maybe a weekend of practice or effort. The rest of these I made using pretty much all the power tools I have in my shop in a manner to reduce the amount of labor I've invested in each one of them, so that I could offer these for sale at just a dirt cheap price to help subsidize a school. But the end result is the same. I mean, look close. Which one of these was the handmade one? I mean, just a little bit of time spent learning the skills, and you can do as well as those big fancy machines that you saw in the store. Now, I'll tell you, this is the one I saw by hand. And yes, I'm sure there's some people out there that were saying that, hey, even the basic way you showed us, you had to buy tools. Well, yeah, I showed you a very limited set. And I'll admit, the tools I showed you that I was using, they were nice tools. They're not the most luxurious ones out there. I mean, you can always go upscale. But they got the job done. And there are still less expensive examples of those out there that if you don't want to spend that much money, you can go that route. Yes, there is a small investment, but it's not what a lot of people think it takes to get into woodworking. And just don't troll yourself. Don't think that you have to have that big, huge shop in order to make a single product. Now, if you're trying to make 1,000 of them, that's a whole different animal. But if you're watching this video, you're probably still learning. You're not at that level right now. So don't troll yourself. Don't give yourself mental blocks to accomplishing simple things. And with that in mind, I hope you realize that this video was not about creating a dovetail marker. There are lots of different ways of doing stuff in woodworking. The ways I showed you here are probably not the best ways out there. I'm sure there are many of y'all out there that will leave comments explaining even better ways, more efficient ways of doing that. Some of y'all might just say, hey, buy a better table saw so you can make straighter cuts so that you don't have to use a drum sander. Hey, investing in better equipment to making things more efficient, more profitable, that's where a lot of people are going. But you don't have to start out at that level. Well, I hope you enjoyed this video, and if you did, please understand, I'm trying to work on this value for value proposition. So if you liked it, please do me a favor, like, favorite, subscribe, do all those social medias. That's the best marketing I can do out there. And if you want to further support this a little bit more, visit my website, wortheffort.com, where not only do I have a lot of swag and ways you can donate stuff, but I have all these shop-made products I make here that you can purchase to help subsidize this channel and my content creation. And I want, in the end, for you to remember one last thing, that it is always worth the effort to learn, create, and share with others. Y'all be safe and have fun.